LRO is the spacecraft that LROC got a ride to the moon on. And LRO came out of the return to the moon, which was the vision for space exploration that was announced by then President Bush. And NASA was reassessing, what are we doing? Where are we going? It was like, oh gosh, we're going back to the moon. Where are we going to go? What are we going to do? And it was realized we hadn't been there since the 1970s. So the NASA and the science community realized, well, we've got to get more measurements. If we're going to really do this smart, we need to have holistic knowledge of the geology and geophysics of the moon so we can pick the best places to go. You don't want to just be randomly landing on the moon. Goddard Space Flight Center was requested to build this lunar orbiter. And then NASA decided that, well, we're going to let the science community pick what instruments go on it. Well, we told NASA why this was critical for a human return to the moon, and they said, okay, build it. Eventually, 6 other science instruments were on LRO. The original mission was only supposed to last for 3 years, and now we're in our 10th year, and we're still returning incredibly useful science data. LROC is actually, it sounds like one camera, but it's actually 3 cameras. 2 identical, narrow angle, very high resolution. It's actually, we can see the tracks left by the astronauts, so you can get a feeling for what high resolution means. And then there's another very small camera. It's about this size. It's called the wide angle camera. Each pixel is about the size of a football field, but it pictures the moon in 7 different colors, 2 ultraviolet bands, and then 5 visible bands. And from that, we've mapped out mineral abundance and learned a lot about ages of the surfaces of the moon. Between those 2 instruments, we're really trying to determine the best place to land. And once we find the best place to land in a big picture sense, then we can use the incredible ultra-high resolution of the narrow angle camera to actually pick the exact place to land based on its proximity to scientifically interesting rock units, or maybe something that could be used as an ore. And that was really the goal, is where can we go to do science and also look for ore bodies. My role is, this much of that, and you have these dedicated people who come to work every day. They make sure that the camera's working correctly, that the commands are right, that we get the images that we need. And also the same can be said for the operations team at Goddard Space Flight Center who actually operate the spacecraft. And you don't want to lose sight that it's because of these people that we continue to make these scientific discoveries. And now it looks like we're actually going back to our original purpose of helping find the best places to land humans on the moon.